Okay, welcome to another episode of DataStructures tutorial. Today, I know it's been a while. It's been about 3 months since I've done anything, um, and I wanted to get back on this. Um, the last thing we implemented was our stack. Um, and there was an error if you guys were following. When we in the Node.h, when we set the data, there was a bug there. If you ever try to use it, you wouldn't be able to set any new data inside of it because we were checking here that to make sure that the data or iData was not 0. And what I wanted to do is actually say that the new data that was coming in is not 0. So if we do this and we try to set data, now we will be able to set anything as long as it's not 0. Um, so what are we going to do for this? For this example, I have this file. I called it stacks.txt, and it's just code. Doesn't really do much. It won't compile. Um, Probably, maybe it will. Who knows? But what I want to do is to show you guys how stacks can be used. And we're going to create a parser. We're going to load this file into memory, and we're going to check to make sure that these things, the opening braces, brackets, and um, these things, I forget what they're called. I don't know why. We're going to make sure that they match. So let's get started on that, yeah? The first thing we want to do is we want to include our stack that we implemented last time. And if you guys are following and maybe this is the first time, I would encourage you guys to go back and look at the other tutorials. But I made a repo where anybody can download and fork. Oh, what the hell? GitHub. There you go. So anybody can go in here and find my repository, and it's called Wulfers Toolbox. In here, you will be able to. I'll be uploading every tutorial that I make within this series of data structures into here, so you guys can download the zip or fork it into your own repository and follow along. So yeah, so we include the stack.h so we can use it. And to read the files, I'm going to use the Windows API. So if you guys want to follow along and you have, if you have Windows, then you will be able to use this. Otherwise, you will have to use the standard library. I believe it's fstream. So yes. Let's get rid of this guy. And the first thing we want to do is create a stack. And it's going to be of type char because we're going to be reading each character. And if we find one of these things, we're gonna, add it into our stack. So I'm gonna call it open delimiter, open delimiter stack. Okay, and we don't have to allocate it into the heap. It's just going to be allocated into the stack of our memory. The next thing that we want to do is we want to be able to create the file, not create the file, but load the file into memory. To do this, we first have to call this function. Okay. And if we go and look for it, we can go to just say that MSDN. We go in here, you'll see what it does and what parameters it takes. And here's a description of how to use each parameter, what to pass into it, and whatnot. Okay, I'm going to copy this whole thing so we have a template to work with. And if you notice, this create file returns a handle. A handle is just a void star, so you can just say void star here, but we're just going to leave it as that. And we're going to call this handle to this file. Just call it file handle. The next thing we want to pass into it is the string, the name of our file with the extension, which is txt. Okay. The second parameter is the desired access. It is how you want this to be handled. Well, since we want to read it, we want to pass it generic read. If you want to write to a file, you would pass in generic write. And if you want to do both, then you can pass it just or these two masks, I guess, into this parameter. So all we want to do is just say generic read. The next thing we want to do is set the share mode, but we don't really need to worry about the share mode. This is just something that says, I believe, if you set it to 0, nobody can use it while you're using it. But if you say file share delete, then it enables other processes or operations to delete this file, even though you haven't still open, and so on with these as well. But this is read and this is write. But we don't want anybody to mess with that file when we are reading it. So we're going to pass in a 0 there. Security attributes is going to be a 0 as well. The creation disposition, this one is the action that we want to take on a file. So since we're just reading it, we want to make sure that we only open existing ones. If you were trying to create a file and it didn't exist, then you would always do this, create always, But we want to make sure that this file exists. We don't want to create anything else. So we would just pass in open existing and flags and attributes. That can be 0 and that can be 0 as well. Now that we have this file handle, we want to make sure that we actually have it, because if the file does not exist, we will fail and it will return something called invalid, not invalid, invalid handle value. And we want to do here, the next thing we want to do is get the file size of the entire file. So we know how many bytes we need to read in order to get every piece of data that is within it. After we do that, we actually want to read the file. Read entire file into a buffer. And after that, we want to just close the file. And we can just do this right now. To close a file, we just gotta say close handle and pass in the file handle that we got from the first, from this create file function. Get file size. We are going to use the extended one. This extended get file size, it's going to take in two parameters. The first one is our file handle that we just created or got back from the create file function. The second parameter is a structure that it will modify it with the actual file size of the file we're trying to read. And this is a large integer. If you guys don't know what the the large integer is, it's just it's a structure and it has a union inside, and it's got three parameters. It's got a low, and if you guys want to see it, we can do this. It's got a low part, which is an unsigned integer. And it's got a high part, which is just a regular integer. And these two are 32 bits each. The quad part, it's a long, which is just a 64-bit integer. And it pretty much mixes these two. So if our file size was greater than 32 bits in size, then it would, store the first low part here, and then if it's greater than that, it'll store that, and this will allow us to extract each part of the full length of the file or this integer without having to shift or mask any bits. So it's a pretty handy thing to have. So we are going to pass the address of the file size for this function to modify our value. And then after we get the size, we are going to call readFile. What readFile does is it takes in several parameters. The first one is the file handle, because it's got to know which file we want to read off of. The second is a void star, and this is what we're going to be writing our data into, and we call this the buffer. So we're going to pass in a buffer. We don't have one yet, so we have to create it and then allocate memory into that, so we have enough space to store the size of the whole file inside of that. And we will be using this buffer to do our operations to check if we have a delimiter or not, and we can do all sorts of things with this, but we're going to be using that for this tutorial, or part of the tutorial. The next parameter is the number of bytes that we want to read. And we already have this. It's our file size, and we're going to pass it the quad part, or the full length, if it had 64 bits or bytes. I get confused. Anyway, the next thing is going to be, it's gonna give us the actual bytes that it read, and it's not always going to be the exact thing that we want to read. So it's gonna tell us how much it actually read from this file, and we want to pass it the pointer, the pointer, the address to that integer. And the last parameter is 0. Okay. So up here, before or after we create the file, because we're not really creating it, we're just getting a handle to a file that we want to read. We are going to initialize our buffer and set it to null. Okay. And we also, down here, we want to make a unsigned integer and call it bytes read, and for this file to use and fill out the actual bytes that it read. And then we can also check here to make sure that if the bytes read equal the file size, then we actually read the whole file. And we can just, for future reference, if we're trying to debug this later on and we don't actually read the whole thing, we can output something here to know what happened, or where the error might have been. But we don't have to do this. We don't have to do anything there right now. The next thing we have to do before we can read the file into the buffer and write to it, we have to allocate some memory into the heap. And we are going to be using a function called virtual alloc. And the first thing is going to, well, let's look at this guy over here so you guys can see some of the parameters that it has. So this file, this function reserves, commits, or changes the state of a region of pages in the virtual address space of the calling process. Memory allocated by this function is automatically initialized to 0. So we don't have to worry about, initializing it properly. And this is what it takes. It takes an address. This is the base address, where the starting point of your memory that you want to allocate. If you want to read more about it, it's right here. The D word size, it's just the amount of bytes you want to allocate. And if you want to read more, it's right here. It says the size of the region in bytes. If the LP address parameter is null, this value is rounded up to the next page boundary. Otherwise, the allocated pages include all pages containing one or more bytes in the range from LP address to LP address plus keyword size. This means that a 2-byte range straddling a page boundary causes both pages to be included in the allocated region. So yeah, we're going to be passing the file size that we want to read. The allocation type. This is the type of memory allocation. This parameter must contain one of the following values. It cannot be 0. The first one is memcommit. And if you want to know what that does, it just, you can read it here. Then we have memReserve. So we're going to be wanting to use these two together. If you read here, it says to reserve a commit page or pages in one step, call this like this, and blah, blah, blah. So we want to do that. And you can also do other stuff like this, depending on what you want to do. And the last thing is the protection of the region. Whether you can read to it or write to it or, whatever. Some of the constants can be found here if you click that link. And what we want to do for that is read and write, page read write, because it will enable us to do read only or read and write access to the committed pages of the region. So if we go back here, the base address is going to be 0. We don't really care about the base address. The dword size is going to be the file size. What part? The allocation type, it's going to be memReserve and memcommit, and we have to OR this. Damn it. You have to OR them together so they get 2 bytes merged together. So this function knows what we want to do. And the last thing was page read write. Okay. And this function returns, just like malloc, this function returns a void star. Since our buffer is a void star, we don't have to cast to anything, and we just declare it like this. And also another thing we want to do, if we actually have something inside of here, and it's, not invalid memory. We want to check that, and if we do have something in it, we want to go ahead and read the file. Otherwise, this will just fail, and I don't know if we might crash or not, but it is possible, I guess. Pretty sure you would crash. And right here at the end, we have to release or free the memory that we just allocated at the end. And to do that, there is a function called virtual free. We pass in the address, so it's the buffer, and 0 for the dword size, because we want to, we want to do the whole thing, and the last parameter just takes in mem release. And before we do that, we also want to make sure that we do have memory allocated. Otherwise, we will crash if we try to free anything that it's not there. Okay? So, now we can test this and see if we actually read anything or not. So I am going to put breakpoint right there, and we're gonna step through this call or these calls. So we want to see if our file handle exists. We want to see if the buffer has any memory. We want to check the file size and the bytes read. Okay, so you can see here that we actually got a file handle. We just set this to null, so we don't have any memory right now. Here we check to see if the file handle is not equal to this, and it's not. Then we get the file size, and you will see that this thing right now is, invalid. And boom. Okay, file size is 228. So we can go over here, right click on this guy. Oh, we don't even have to do that. Just click here and look down here, and it'll say 228 bytes. So we successfully read the whole file. Well, we didn't read it yet. We just got the size. So we know what the size of our file is. And we try to allocate memory, and you can see now we have our base address, and we check to see if we do have something in here, then we want to read into it. And right now we can see that we have not read anything yet because bytes read are, unset. But once we pass this function, we can see that the bytes read are the same as the file size. So everything that we wanted to read, we read successfully. And to check if our buffer has any of that data we wanted, we gotta cast it down to a char star, or a string, if you will. And we want to look at, I don't know, the first, not 1003, first 100 bytes. And you can see here, it pretty much matches this, right? Okay. So we have successfully read this file. Now, we don't want to use this buffer directly. Otherwise, because we're going to be shifting the memory from, from the base, from the starting point, we're going to be shifting it to check every byte inside of it. So we don't want to use this because we're going to lose our place and we won't be able to free this memory later on. And if you see, I believe somewhere it says that when you do a, where is it? Maybe we have to go into this function, but it will actually tell you that if this call will fail if the um, if the base address that you got back from the virtual alloc does not equal, is not the same, then this thing will fail. Releases the specified region of pages after this separation. If you specify this value, keyword size must be 0, and LP address must point to the base address returned by virtual alloc when this region is reserved. The function fails if either of these conditions are not met. Okay? We got to make sure that we don't mess around with this guy. So we got to copy this into another buffer. And we're just going to do this. We got to cast it to a car star because it's a void star right now. Okay, so now we got it in a different place, or it's the same place, but we're reading from it. So now what we want to do is we want to loop through it. We want to loop through read buffer and increment it every time. And we want to make sure that we want to read everything from start to finish. And usually I believe that at the end of the file, we have a terminating string. It is this guy right there. So if we reach this guy right there, we note that we are at the end of the file and we will get out of this loop. And what do we want to do first? Well, we want to check that the or check if there are any open delimiters. If there are any, then we are going to add them to the stack. Okay. So that's going to be our first case. Second one is going to be check if there are any closing delimiters. And I should probably add this guy, this guy, this guy. So if we read we find that the file contains any of these, we're going to put them inside our stack. Okay. And then if we find that we have the opposites, then we want to first make sure that the stack is not empty. Because if the stack is empty and we found one of these, that means that these were not found, so there's no match, right? So we know that our file is missing one of these, and we should get out of there. And the last case is oh yeah, no, not the last case, because we still need to do more stuff here. If the stack is not empty, then we want to extract the open delimiter and compare it to the closed delimiter and see if they are the same, to see if they are the same. If they are the same, then we continue. Otherwise, we get out of the loop. And if there are any other characters that are not delimiters, then we want to ignore them and keep looping, right? So that is what we're going to do. So the first thing we should do is this. So if the read buffer is any of these, so we're going to copy that. If there are any of these, then we want to push them into our stack. Okay. Now, if they are the opposite, which we can just copy this, put it there, and say if there are any of these, and we're just going to put it there. Then we want to make sure that the open delimiter stack is not empty. If it is, we're just going to break, right? Otherwise, we are going to, let's see, if the stack is not empty, then we want to extract that. Okay, so we want to do this. We want to extract it. How do we extract it? We use the peek function. Remember, the peek returns a character or whatever type our stack is. After we do that, we want to check. Well, we want to make sure that once we extract this item from the stack, we want to get rid of it. We don't want to see it anymore. And then we want to do an if statement saying that if the delimiter, which is the open one, if it equals this guy, then we want to make sure that the read buffer matches this one, right? And we can put this all in one thing, copy it, and because we're going to have other ones. Okay. Yep. So we want this guy, and this guy, and this guy, and this guy. So if they are that, we just want to continue. So we should check that these are actually not the same. So if they don't match, then we just want to break, right? And that should be that for that. Otherwise, we don't really need to do anything there for now. We just want to loop. Okay? So now we want to check if the open delimiter stack is empty. If it is empty, then we know that we were successful and we don't have any, mismatching delimiters. So you just want to print all delimiters matched, right? Otherwise, we can print let's say we're going to pass in the size of the delimiter, the stack. We're going to pass in the size of the stack, and we're going to say, okay, we want to show here where %d is how many elements we have in our stack, and that's how many did not match, right? So number delimiters did not match. And we want to pass in the open delimiter dot size. Okay. And we can also print out so we can see it in here. We can print out our buffer. Sorry. So we can say, I believe it's S for string. And we'll just space it out a little bit. So this function will replace anything that you pass in here with the percent sign. And like, let's say you have %s, %d. %s says, I want you to replace this with a string, and this %d, replace it with an integer. And you would have to make sure that these are matching with these in order, okay? If you have never used this function before. So now that we have that, we are going to set a breakpoint here just in case, and we're going to run it and see what we get. Okay. So we can see that we read the file and it says, you know, blah, blah, blah. We get this guy, everything should match. And here it says all the delimiters matched. Okay. Now let's go back to our file and let's just delete one or two. Let's delete two. And we are going to run it. All delimiters matched, huh? Are you sure? Probably because we never. That happened because, as if you can see here, we only have a closed one at the beginning, right? And if we do check that we have any of the closed ones, if we say that if our stack is empty because we haven't added anything to it, we're going to break. And here we assume that if it's empty, then, you know, we automatically think that it's good. It's good to go. But that's not the case. So what we want to do is have a Boolean as well. So we're going to say Boolean delimiters matched, and we're going to set it to true for now so we can be instead of this function, and we're going to say not that delimiter, oh, delim matched. So as long as this should probably, yeah, okay, yeah. So as long as this is true, we're gonna keep going, right? So instead of breaking here, we're gonna say delim matched equals false, right? We're gonna copy that, and then we're gonna say this, else true, right? and then else, because if we just leave it like that, it will probably not work correctly. So for any other one that is not, that we don't care about, any bytes that we don't care about, we're gonna just set it to true because we're not checking to see if it's a delimiter or not. Okay? So now when we do this, we want to check if the if it matched and it's empty, then we found everything. Otherwise, we're gonna print this. And we go here and we see that we have this error. Now it shows 0 because, as we discussed earlier, nothing got ever set inside the stack because this guy was here first. But if we change it, just leave it with this guy missing, then we should get something else. Now, let's save it. I did. Well, that matched that. This guy's floating around. This guy matches that guy, that guy, that guy, that guy. Interesting. Oh well. We're not gonna worry about that just yet. Now, we have it all set up how we want it, but we can hide some of this stuff in functions, right? So we can make 1, 2, 3 functions. First function, and they're all gonna return bool, and it's going to be called open delimiter found, and we're going to pass it a char, and we're going to name it symbol, and we are just going to get this and just cut it and return, paste it there, and this, paste it in there. So we're just going to be extracting this check. So it's easier to read. And if any of these is true, it's going to return true. If none of these are true, then it's going to return false, right? So yes. And here we're going to say if open delimiter found, and we can pass in the read buffer to it, and that should be it for that. Then this guy can be another function called close delimiter found, and pass in a char symbol. And we're going to just do the same thing as we did up there and return that change this, that, that. Let's align them properly and pass it here. Whose limiter found, as in the read buffer. And the last one that we can do is this guy right here. And we'll also return a Boolean. And what should we name this one? This one is checking to see if they matched. So let's call it delimiter matched. And we have to pass in two things. Let's call it open delimiter and close delimiter. This one needs to be var as well. And paste it in there. Return that. And format it. So this guy is that. This guy is that. And we actually want to check that they do match. Because our name of the function says that they match. So we want to do what it says, because otherwise we'll get confused. Okay, so now instead of doing this if else statement, we can just say this guy equals whatever this returns, which is going to be the delimiter and the read buffer, right? What? Expression preceding parentheses of current call must have pointer to. Can't name it that. Because, yeah, we already have this that is called delimiter matched. So hard coming up with names. um, I don't know. Open, close, delimiter match. So where are we? There. Okay. Now let's run this again. We should get the same outcome. Oh, look at that. One delimiters did not match. So we actually are doing something now correctly in a way that when we were just doing it all in that place, we weren't doing something correctly, I guess. But now we are, so we detected that one was not found. It didn't match the other opening one. So yeah, that's pretty much it. I mean, we can now potentially open, let's open our TNode.h, and it should work theoretically. So we load it, and all the limiters matched. What do you know? There we go. So we can see that it read the whole file, it printed it, and it told us if it matched or didn't match. So yeah, that is the basics of finding the limiters. We can get more fancy later on, or if you guys want to do it more fancier, you can show the line number where this did not match, or something else like color, whatever did not match, so you can see it. And there's a lot of stuff you can do with it. So yeah, I'm gonna stop here. The next tutorial, I believe, is going to be on queues, which is similar to stacks. It's just the other way. It's the stacks are last in, first out. So you're going to pile them, but you can only get it from up top here. The queue is first in, first out. So we're going to be getting them like this, stacking them up, and then we can always get the first one we ever input it there. And these are useful for a lot of things. I've mostly used them in mm, artificial intelligence, where you have to find a path, the shortest distance between nodes, what shortest path to go through. You get each node and you put it inside a queue, and then you check like distances, weights, whatever, and you find the shortest path like that. We use those there, or you can also use stacks, but then you'll be going backwards or something. um, yeah, there's a lot of uses for that. If you guys like this tutorial, don't forget to comment, subscribe, like, anything like that. If you guys want to see other tutorials, um, let me know what kind of tutorials you want to see. I do want to start um, game development tutorials, but we still haven't done. We're still not done with this series, and there's a lot of cover for that. So maybe I'll branch out to other ones and do one-on-one, maybe 2 every week. I hope. There. I'm not making any promises, but yeah. If you want to follow, follow with this, you can get the code on my GitHub. Just follow, search me, George Wulfers 88, Wulfers Toolbox, and you'll see this here. I will upload this every time I make a new tutorial. So yeah, hope you guys have a great day, great weekend, and I'll see you later. All right, bye.